Above all, the universe never fails to captivate us with its staggering diversity. The sight of countless sparkling structures scattered across the night sky constantly reminds us of how small we truly are in the grand scheme of things. But beyond these innumerable celestial objects lies something quite the opposite: vast regions defined not by brilliance, but by haunting emptiness and impenetrable darkness. One of the most striking examples of this is the Boötes Void, a cosmic region so vast and desolate that not only continues to puzzle astronomers, but has also become the subject of numerous speculative theories about advanced alien civilizations. So, what exactly is the Boötes Void? Does it really contain nothing? Or could it perhaps help us answer some of the most profound questions in astronomy? To understand what makes the Boötes Void so mysterious, we first need to grasp the concept of a void in the cosmic sense. At the largest known scales, the universe is structured like a giant web or a honeycomb. This is due to what scientists call filaments, massive, thread-like structures composed of both visible and dark matter. These filaments connect galaxy clusters and superclusters, which are densely packed with galaxies. Now, the vast spaces between these filaments, the empty bubbles in the cosmic web, are what we refer to as voids. These regions contain very few galaxies relative to their immense size, and they can stretch for hundreds of millions of light years across. Because of its extreme emptiness, some theories propose that something or someone may have intentionally created or influenced the void. The Boötes Void is one of the largest and most intriguing of these regions. Spanning a jaw-dropping 326 million light-years, it's not just a random empty spot in space. It's a major anomaly that challenges our understanding of the universe's structure and evolution. Just to put things into perspective, a single light-year equals roughly 9.46 trillion kilometers. So, if we assume a galaxy moves at a typical speed of 600 kilometers per second, it would take more than 160 billion years to cross even an average-sized void. But the universe itself is only 13.8 billion years old. That makes it extremely unlikely that these voids were formed simply by galaxies drifting apart over time. Instead, the current understanding suggests something far more profound. Both the filaments and voids of the universe were formed roughly in the positions they occupy today. But this raises a deeper question: what caused this particular cosmic arrangement? We know that ordinary matter in the early universe was far too evenly distributed to produce such large structures through gravity alone. That's why scientists believe dark matter played a key role, a mysterious, invisible substance that significantly influences the movement and distribution of visible matter. Though we still don't fully understand what dark matter is, its gravitational effects are essential to the formation of the universe as we see it today. So, what exactly is hidden within the Boötes Void? Sometimes referred to as the Great Void, this term can be misleading. While the Boötes Void appears nearly empty, it's not entirely devoid of matter. It's defined by its extremely low galaxy density. Named after the Boötes constellation where it's located, the Boötes Void was first discovered in 1981 during a study of the redshift distribution of galaxies. This is a massive spherical region, and despite its size, it contains only around 60 gravitationally bound galaxy clusters. Now, that might not sound too strange until you consider the scale. The Boötes Void spans about 300 million light-years in diameter. That's around 0.27% of the diameter of the entire observable universe. And its volume? A staggering 236,000 cubic megaparsecs. By all calculations, a space this large should contain more than 2,000 galaxies, but we only find 60. To get a sense of how empty that is, imagine this. If our Milky Way galaxy were at the center of the Boötes Void, it might have taken astronomers until the 1960s to discover that other galaxies even existed. On average, in this region, you'll find just one galaxy every 5.5 million light-years. It would take billions of galaxies like our own just to fill the Boötes Void, and with today's propulsion technology, it would take us around 13 trillion years just to reach the nearest superstructure, 700 million light-years away, and another 6 trillion years to cross through it. Sounds mind-blowing, right? But here's the real kicker. The Boötes Void isn't even the largest void in the universe. At the top of the list is the KBC void, also known as the local hole or local void, which spans a mind-numbing 2 billion light-years across. Then there are the Eridanus supervoid and the Sloan Great Wall void, each extending over 1 billion light-years. While these voids may feel overwhelmingly empty or even eerie, they play a crucial role in the scientific understanding of the cosmos. They help astronomers test models of the universe, refine simulations, and explore the role of dark matter and cosmic evolution. At first glance, the Boötes Void might seem like a rare oddity. The fact that it contains only 60 galaxies instead of 2,000 represents a shocking 95% absence of matter. But its sheer scale and the existence of even larger voids challenges the idea that it's an anomaly. In fact, the study of voids is a lot like studying photonegatives. We learn from what's missing rather than what's present. And as we map the universe in greater detail, what we see increasingly resembles a massive cosmic spiderweb. Galaxies mostly gather along the filaments, those thread-like highways of matter, and between them lie the voids, the vast dark patches that still hold some of the greatest secrets of our universe. As we mentioned earlier, voids make up an astonishing 80% of the observable universe. These vast regions of emptiness lie between dense clusters of galaxies, where cosmic filaments weave the largest known structures in the cosmos. Our own Milky Way, for example, is part of the Virgo supercluster, which itself belongs to the even larger Laniakea supercluster. So while filaments and clusters mark the dense threads of the universe, the Boötes Void is just one of the countless empty pockets between them. But even though we now understand what voids are, one fundamental question remains: why do they exist at all? To find answers, we need to rewind the cosmic clock back to the Big Bang, around 13.8 billion years ago. In those earliest moments, the universe was incredibly hot, dense, and uniform. However, quantum fluctuations, tiny, random variations in density, led some regions to become slightly denser than others. These denser pockets began to pull in more matter through gravity, eventually growing into the galaxy clusters we see today. Meanwhile, the less dense regions, the spaces that didn't attract much matter, became more and more empty over time. As the universe expanded, this process exaggerated the differences, carving out vast voids and connecting them with matter-rich filaments. To visualize this, imagine a foam of bubbles expanding in slow motion. The voids are the growing bubbles, and the galaxies form along the thin surfaces separating them. Joseph Clampett from the University of Pennsylvania once described it this way: voids are extended, flat valleys in the distribution of dark matter, while galaxies lie at the center of narrow towering peaks. A typical galaxy has the same height and footprint as the Empire State Building, and a medium-sized void would be a 3-foot deep hole, 3 times the size of Manhattan. In essence, the Boötes Void is likely a fossil of the early universe, a relic from a time when matter hadn't yet clustered evenly. It grew over billions of years to become one of the largest structures we've ever observed. At least, that's the view held by most mainstream scientists. But in more speculative circles, the Boötes Void sparks some truly bizarre theories. One such theory claims that the Boötes Void might be a giant black hole. While intriguing, this idea doesn't quite hold up. Take Ton 618, one of the largest black holes known. It weighs 66 billion times the mass of our Sun, but its event horizon is just 0.2 light-years across. In comparison, the Boötes Void spans 300 million light-years. To be a black hole of that size would require an unfathomable mass, far beyond anything observed or predicted. So, this theory, while fun to consider, is extremely unlikely. Another wild idea? That the Boötes Void doesn't actually exist. Instead, some suggest it could be filled with Dyson spheres, massive, star-encompassing structures proposed by physicist Freeman Dyson. These hypothetical megastructures would completely enclose stars to capture all their energy, rendering them invisible to our telescopes. If an advanced alien civilization had built Dyson spheres on a galactic scale, that could explain why the Boötes Void appears so empty. It's not truly empty, just hidden from view. Of course, such a theory borders on science fiction, but it's a reminder of how little we truly know about the universe. So what seems more likely? A galaxy-spanning civilization that cloaked billions of stars, or simply a naturally occurring region of space that happens to be more empty than average? Whatever the truth may be, one thing's for sure: the Boötes Void challenges our understanding of space, time, and cosmic structure. And if you like to keep filling the void in your knowledge, don't forget to like, subscribe, and turn on notifications. We'll see you in the next video.